Salinity is the amount of salts dissolved in water, and it is expressed in parts per thousand. The average salinity of ocean surface is 35 parts per thousand, which means that 1,000 grams of ocean water consists of 35 grams of salt and 965 grams of pure water. Always remember, salinity increases when there is evaporation of seawater and freezing of seawater, while salinity decreases when there is precipitation over the ocean, melting of glaciers and icebergs, and fresh water input by rivers and groundwater. And now, it's solving time! On the average, a sample seawater will have a salinity of 35 parts per thousand. How much salt can be extracted from 325 grams of seawater? Now let's try to answer this problem. On the average, a sample of seawater will have a salinity level of 35 parts per thousand. How much salt can be extracted from 325 grams of seawater? Now, our problem is how much salt is present in a 325 grams of seawater with a salinity level of 35 parts per thousand. So very simple. Let's just use this modified formula. Let's just let X as the amount of salt. Okay? And then over 325 grams of seawater, this one is actually from our given, and then is equal to 35 grams salt. This one is actually from the value of this salinity level, which is 35 parts per thousand, over 1,000 grams of seawater. Okay, now let's just perform the operation. X equal to 35 grams salt times 325 grams seawater. Use your calculator, divide or over 1,000 grams seawater, and you will have this result. X is equal to 11.375 or 11.38 grams of salt. So that means that in every 325 grams of seawater with a salinity level of 35 parts per thousand, there is 11.38 grams of salt. Very simple, right? John Rex fetched 5.5 kilograms of seawater with an average salinity level from Sarangani Bay. Identify the amount of pure water in grams. Okay, we have another problem here. John Rex fetched 5.5 kilograms of seawater with an average salinity level from Sarangani Bay. Identify the amount of pure water in grams. So our problem here is we will identify how much pure water is in that 5.5 kilograms of seawater from Sarangani Bay with a regular salinity value, which is 35 parts per thousand. That's our problem. Okay, so very simple. Let's just use again the modified formula, and then let's fill in the values. Okay, so let X as the pure water over 5,500 grams of seawater. Now, where did we get this 5,500 grams? So we have here 5.5 kilograms of seawater. Let's just convert that into from kilograms to grams. So let's just multiply that into 1,000 and you'll get 5,500 grams, okay? So we have 5,500 grams of seawater is equal to 35 grams of salt. Again, this 35 grams of salt is from the value of the salinity level, that's 35 parts per thousand. As mentioned, average salinity. So we'll just use that one, okay? And then over 1,000 grams seawater. water. Okay, now you perform the operations. X is equal to 35 grams of salt times 5,500 grams of seawater over 1,000 grams of seawater. And here you'll get X is equal to 192.5 grams of salt. Now let's go back to the main question. Identify the amount of pure water in grams. So this is not yet the final answer. So we have additional operation here. So 5,500 grams of pure water minus the amount of salt, which is 192.5 grams, and you'll get 5,307.5 grams, and that is the pure water. And that's the answer to our question. Amount of pure water in grams. Easy, right? Dimash, Vitas, and Cherise mix 1,500 grams, 4.92 kilograms, and 0.92 kilograms of seawater with an average salinity of 40 parts per thousand from Lions Beach, respectively. Solve for the amount of salt and pure water in grams. Okay, let's try this problem. Dimash, Vitas, and Cherise mixed 1,500 grams, 4.92 kilograms, and 0.92 kilograms of seawater with an average salinity of 40 parts per thousand from Lions Beach, respectively. Now solve for the amount of salt and pure water in grams. So our problem here is we will identify how much salt and how much pure water is in from the gathered or from the mixed water fetched by Dimash, Vitas, and Cherise from the Lions Beach with a salinity level of 40 parts per thousand. Okay, so first thing, let's just add up the amount of the seawater. We have Dimash 1,500 grams, Vitas 4,920 grams. That's from 4.92 kilograms. Convert into grams. You just multiply into 1,000 and you'll get this value, 4,920 grams. And then Cherise got 920 grams of seawater. You just add the amount of the seawater. So you'll get 7,340 grams of seawater. Now, so since we have already this one, we can now proceed with the operation. Okay. So again, use the modified formula that X is the amount of salt over 7,340 grams of seawater and is equal to 40 grams of salt. We'll now use 40 grams. It's because the given is 40 parts per thousand. So we just found this one. So the salinity level is 40 parts per thousand over 1,000 grams of seawater. Okay, now X is equal to 40 grams of salt times 7,340 grams of seawater over 1,000 grams of seawater. And we'll get 293.6. And this is the 293.6, and this is the amount of salt. And we're done with the amount of salt. Now, we still have one problem. The amount of pure water in grams. So, very simple, you just subtract 293.6, which is the amount of salt, to 7,340 grams, which is the total amount of seawater. Okay, so 7,340 grams minus 293.6 grams, and we'll have 7,042.4 grams as the amount of pure water. So that means that from 7,340 grams of seawater with a salinity level of 40 parts per thousand, we can have 293.6 grams of salt, and the amount of pure water is 7,046.4 grams. Easy, right?